welcome to another video on this channel. So today we're gonna do two things. So we're gonna install some quality of life features here on the Minuteman machine, the world's fastest printer. And then we're gonna try to hook this guy up. This is a bottle of helium and we're gonna try to use this as our main cooling method for the part. This will come with its very own challenges, and I think we're gonna jump to a point where I thought, well, this might take me an hour or so.
My name is Jan, and I build stuff so you don't have to.
Da 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 da.
It is 2 days later actually. I had a crash on the SD card mid-printing apparently. I think it was due to undervoltage of the Pi, even though it has been on like the official 5 amp power supply, I don't know. So let's go over the machine, what has actually changed from the last videos and what my quality of life updates actually are.
Got to be kidding me.
So as you can see, I installed this new part here and these 3 springs are being attached to it. And now if I for some reason lose power or the main board throws an error or something, it is just staying where it is. And let's say it is being somewhere down here and the motor's shut off, it will actually rise just a bit. But of course the friction here just like keeps it in place. With the springs getting more and more elongated, of course as the forces will be higher and it will be pulled upwards, but in no case the Z-axis will actually drop down, even at the, I mean maybe for the first 10 millimeters, but we're never using that space here. The Benchy is like 54-ish millimeters in height and we got 70 millimeters of travel, so this is being sorted out. And then you can see down here is the micro probe from Big Tree Tech, and I set up this routine. So with the bat already homed, I can hit touch off and it will deploy the probe. Touch up there, and now we got our Z height figured out. And yeah, it's fair to say that would have been smart to do way before. There were times where this machine was running incredibly reliable and I had to do this once per day, essentially homing the Z-axis. But then when we're pushing here for new records, it tended to be like 10 to 15 times and it would have sense to have that on the machine early on. But now we're here. We're not going to use that today, but in case we're going full blast again, I installed this guy here. I will put a link somewhere down. I found this I think on Printables. This is a 5010 fan that is just blowing across the heatsink here. And then I also added a fan to the Pi 5. So the SD failure was either under voltage or over temp. So I think I have both of these sorted out. With that being out of the way, let's talk for a brief second about our today's video sponsor, which is PCBway. So PCBway has been helping out this channel and especially this project for quite some time. As you can see, a lot of those parts here on the machine are actually being manufactured by them. This pulley, for example, has been polyjetted in nylon, as well as these motor mounts SLM printed in solid aluminum. The process is really easy. You hop on the PCBway website, upload your parts in whatever formats you got on hand, select some process parameters, define if there are any fine tolerances or threads, and you get an instant quote. So over the last couple of months I have received literally hundreds of parts from PCBway, and they all went into the machine as final parts or for doing my research work here. The quality has always been top-notch and I'm quite impressed with the delivery times and the consistency of things. So thank you again PCBway for sponsoring that content. Let's go right back into a discussion why helium may be beneficial for our purpose here. Alright, so if you have watched my channel before, you know that cooling is the major bottleneck we're facing right now in high-speed FDM printing. So you can push more filament, you can move axes faster, that's all possible. But if you're not able to cool that filament down in a given amount of time, well, then there's no improving possible. So that got me wondering, what if we changed the cooling media itself? Let's talk for a brief second on the specific differences between air and helium as a cooling media and why it might be beneficial for our purpose here. Helium is weirdly different from air in almost every useful way when it comes to cooling. So starting with the density. It is about 7 times lighter, so it basically also rushes out much faster for a given amount of pressure. We have to take that into account somehow. Then there's thermal conductivity, which is about 6 times higher. So basically helium is able to move heat through itself incredibly well. And then there's the specific heat capacity. It is also about 5 times higher, so that means it can absorb a lot more energy per kilogram. So as you can see, this is a bit of back and forth between positive and negative effects, and we'll have to find out how that affects printing at all. Is it practical? Hell no. Just this bottle, 10 liters, 200 bars, so equal to 2000 liters of helium, was around 150 euros, so just the filling. Okay, to really find out how much volume of air we're actually using on the current duct, we're here at my compressor and we're gonna watch the pressure gauge. We're sitting right at 9 bars right now. This is pretty much a 100 liter tank, so with every bar we're losing, we lost 100 liters. So we're gonna go ahead, switch on cooling, and then I'm gonna record the time and how much drop in pressure we got. So let's see. Alright, so in about 2 minutes we dropped down to just over 4 bars of pressure. And we have 2 data points, so this is pretty obvious. Okay, through this simple test we can derive that this duct is consuming around 250 liters per minute, give or take. That is like our reference number for right now. Which brings us over to this guy. So again, this is a bottle of helium. I strapped on this pressure regulator from welding systems, or mostly used in welding systems. This flow meter is accurate for CO2, so I use it in my MIG-MAG welding setup. What you can also see is that this is the pressure gauge that is directly connected to the bottle. All the regulating stuff happens here. It's just shy of 210 bars of helium inside there. So the question now is, which kind of setup is able to deliver an equal amount of flow compared to the shop air system? And I looked up a few different units of these pressure regulators, and all of them are pretty much, yeah, what you've guessed, for either filling balloons or do welding. And this is cranked all the way to 11. And this is the flow you get out of it, with a side effect of, yeah, helium. But for a fair comparison to shop air, we need to have somewhat even numbers. As far as I know, there isn't an easy or cheap solution to do this with off-the-shelf parts. I mean, there is some, but then I have to buy very specialized equipment that I'm probably just going to use one time only. So I think we're going to run this test unregulated. And this comes with a few safety issues at least. Let me see what I can hack together to make this run at around 250 liters per minute and just perform a first test. If that is somehow working, then we can figure out a sophisticated solution. So I found a solution for now. This hasn't been properly plumbed up. I need to tighten everything, etc. But I just wanted to do a very quick test if like my method here works. And by opening here, you see we get very light flow down there, and that was a lot of flow. So with this basically set up, I will go ahead and redo everything to work properly with shop air. and then dial the machine to a number where like cooling is our limiting factors, and then I will do back-to-back runs to see if the machine is really reliable, etc. Maybe try to capture a run with a thermal camera, and then when everything's solid, then we'll do the switch over to helium. Okay, so what I decided to do is to actually try to match the flow rate. This is at least going to give us the most comparable results. I went ahead, we did the flow test on the shop air early on, but now I put in another restriction. We want to be somewhere in the region where we do have bottlenecked cooling, so we can actually compare what the results are. And I set this to 2.5 bars of pressure, and this is basically the Benchy I got out of it. This is out of the sub 3 minute category, and we will run the same exact code for shop air and helium. I will do another 3 or 4 of these to get a bit more reliable data out of these to see if they in itself are somewhat comparable. And this is decent, 2 minutes 53, I guess. There are a few problems evolving, like here the cooling isn't sufficient. We could have a bit more here on the pillar section, and especially the chimney part is bottlenecked by cooling. And yeah, as you've seen in the explanation, I will try to match the flow. And yeah, to match the flow, we have to dial in the pressure. This is the only variable I can like change in this setup. And to match the results with the density applied, etc., I have to dial in at around 1 bar of helium pressure here. And the way I designed, or maybe this is the wrong word. This is basically all the threads that wanted to mate each other. By no means perfect, but again, I have to work with what I got in my drawers here. And since this is basically teed off directly from the bottle exhaust, we get the flow into our cooling duct over this part, and it should read somewhat reliable pressure up here from what is actually building up inside that line. And again, I'm gonna run this unregulated. So basically the regulator side is my thumb, and I'm gonna try to turn this up and have 1 bar on top of here. So I've already ran 4 back to back. Let's do a 5th. And let's talk a bit about the machine setup right now. So it's kind of interesting to see. I've dialed the accelerations back to 200k, and motor currents are down to 1 amp. This is all way tamed down, and machine's running very reliable. Motors don't get hot. And it is still not a quiet machine, but with everything on full blast, it is just a day and night difference. So these are the 5 back-to-back specimen of Benchies. I think they are looking pretty reliable. Not a perfect sub 3 minute Benchy, but I just dialed in some random numbers, and I think this is good for a test. And we can pretty much pick any of these to compare it to the helium one. And speaking of helium, I'm gonna now invest some time and have this somewhat properly plumbed up. and then we're just gonna hit go on the same exact code, run the thermal camera again, and see what the differences are. Okay, I think I'm as set up as I can be for this test. I apparently had to switch this pressure gauge. I guess what happened is the last one is just up to 2.5 bars, and when I like turned this the wrong direction, I gave it the burst that it couldn't handle. So I have to be kind of careful not doing that again. Yeah, let's see how this goes. I have no idea as well. Okay, this is how far we got. Okay, we didn't make it very far, but I think this is probably the best that could have happened for a first print. This is one of the specimens before, and the 169 is the first we did with helium. And as you can see, it turned out a bit of a mess. But since I do have at least 169 prints of experience on this machine, I think to know pretty exactly what happened here. So as you can see, this is a very integer part. It has a lot of strength, especially in Z direction. This, on the other hand, compare the colors. This is way more matte. This is a bit more shiny. And both of these are printed with the exact same temperatures, etc. But have a look at this. There is basically no layer adhesion. And what this does tell me is a very good thing for a conducted test here, is that we're overcooling. So we're cooling down the filament so hard that the next layer isn't able to melt the previous one. So I'm gonna be running the next one at 0.5 bar, or at least try to do, and see if we're not overcooling. Whoop, whoop. Okay, so very obviously, this is a very well ventilated area, and I was constantly checking my voice if I get like huge amounts of helium breathed in. But I guess it's pretty obvious that you shouldn't be doing any of this at home if you don't think you know what you're doing. Let it put me that way. Okay, this is the second print, and I'm already counting this as a huge win. There are so many variables with the mass flow and the volumetric flow and heat transfer and heat capacity. I wasn't sure what to expect, but previous specimen, first one finished with helium and with very low amount of helium cooling. As you can see, these areas here are significantly better, as well as everything here in the pillar section. We have to take into account that also my cooling duct has a crack in it again. I'm still procrastinating changing it because I just have a single one left. But from this side you can see if the cooling is right, this one's looking really good. A lot better than this one. There is, of course, a bit of stringing, but this is because I'm still running no retracts, etc. So this is more of a printer's fault. But another huge thing to see is how much of a difference it makes in terms of top surfaces. I have run dozens of test prints to see how I can get these gaps closed. And of course I'm in the dilemma of more airflow means more downward force, but I need more airflow to get more cooling. But this one here does look almost what I would call good. And still 2:55 without dialing to the last percent. I'm really stoked about this. So I guess it's time to crank it up again. And I've sliced up a 1:53 Benchy. I got the motor currents back up to 2 amps. This is running at 750k accelerations. I already did a dry run. All the temperatures look fine and it ran through without losing steps. So I think we're just gonna go ahead, and last test was at half a bar. I'm gonna go up again to 1 bar. This is just a guts feeling. Let me see what happens and if we have to dial more or less. Also, I would love to check out the pressure inside the bottle. With this, we could calculate how much flow we had by the given amount of time. But this is a lot of plumbing back and forth for me. I don't want to do that between each run. So I'm just going to go as long as we have some helium inside the bottle. So, same thing, kind of. Let me run half a bar again. It's empty. Oh man, this was working so good. I need a flow valve and additional hardware. Man, I would have loved to see that one finishing. Okay, not gonna lie, at first I was a bit disappointed. It is a few days later, so I would have wished that the second print would have finished and then we would have more comparable data, but speaking of comparable data, I was a bit bummed out about myself. Not properly checking the pressure gauge after the first run, because then I would have noticed that there's way more helium being applied to the print than I was anticipating to. Then we would have had way more test prints and more data points. I should have invested the few minutes to change the pressure gauge again and have a look at the pressure at the bottle. That being said, after having slept a few nights over it, I think we have a counter solution that is actually gonna save the results of this experiment here. Because my whole method was to actually measure the flow of the shop air solution, which is in a restricted state, so it's somewhere around 150 liters a minute, maybe a bit less. And then I wanted to have the helium at the same flow rate to compare the results. What ultimately happened is my calculation was off and we were using way more helium, somewhere in the neighborhood of 280 liters, give or take. What we can do now is kind of reverse it. I got everything hooked up again with the machine being fully unrestricted on air, and we did the measurement before that. It is drawing around 250 liters a minute, which is kind of comparable to the 280 of the helium bottle, which is also not a very exact number. I derived that from the printing time divided by, you know. So we're gonna go at the machine now, take the exact same code, 2 minutes 53 it was, I guess, run it with unrestricted shop air, and then we have a comparable result with the same flow rate, but different cooling medias, and see what the actual differences are. Let's do that. So this is print 170, this is the one to compete with. Let me hit go and see what we got. Et voila! These are, I actually printed 2 of these to get a bit more reliable data, but you can be the judge by yourself. These do look pretty much spot on, so we're just gonna go ahead with one of them and we're gonna compare it to the helium one, and this is really, really interesting. So on the very first glance, the cooling performance seems to be just about the same. At the hull line of the boat, which is a pretty good performance indicator for 3D printing, it is looking pretty much identical. But then again, there are 2 signs that tell me that the helium one has been cooled way more than the air one. This does only mean that the cooling that both of these Benchies have experienced was pretty much enough to cool down the requested layer times we had here, and I think this is 0.6 seconds. But there are 2 things to take away from here. On top of being just able to cool this, have a look at this here. Let's just compare this to top fills. Here on the boat, real top, and then here on the deck. So cooling performance aside, we can just see that the 7 fold density of air. This is where it shows. Basically, we have a force that is being applied onto the extruded filament that is 7-fold than this extruded material here experiences. And at that flow rate, this does seem to make a real big difference. These are almost flawless. But if you remember, a few episodes back, I was doing back-to-back tests with just this top fill being analyzed, and I wasn't getting anywhere with it. But now we do see that it is possible with the current settings on extruder and pressure advance, etc. This is looking like a really well done bridging and surfacing application here. Another thing I've noticed is very subtle and maybe just seeable for me, but there is actually a difference in the glossiness of the filament. This is a bit more glossy than this one. So if I push this really hard here, maybe just the slightest bit of crackling sound. But here, I just did it before and I actually split it right here. And you can hear that? This tells me again that there has been way more cooling than on this here, because the layer strength isn't on par with the shop air cooled one. Therefore, we have taken a lot more energy out of the previously deposited layer after applying the next one. We can see that in the strength in that direction. The last coffin in the nail are these overhangs here on top. You can again see that there's a lot less of downward force here. I haven't removed any of the stringing. This is just as is from the machine. Everything you see here stringing wise is a thing that can be attacked with different PA settings or temperature. Again, this is nowhere near 100% dialed in for this speed. This is just a random slicer profile I came up with. So yeah, things we know. Helium does work as a cooling agent on 3D printers. B, it is really expensive. Again, let's say this Benchy was around 75 euros of cooling media, which is kind of absurd. What we don't know is, so basically we could assume that if we go on a real competitive Benchy like the 1:30 I did just the other day, that if we find the right amount of flow, and there is a lot to be gained here. So the 280 liters was pretty much at half a bar on the pressure gauge. We could go to 1, 2, 3, 4 bars, whatever, and have flow of 1,000 liters a minute, but still would be lower in terms of pushing force than 250 liters of air cooling. So with the right parameters, this would probably be the most potent cooling setup I ever had on the machine, even compared to the liquid nitrogen stuff, etc. But then again, on these flow rates, basically a Benchy would be 150 euros a piece. I don't know if I want to go that route, because everything has to line up. And with the shop air approach, something does not work in a world record attempt or something, well then rewind and start again. But if you've already used half of a bottle and something breaks or lifts off the build plate or something, well then I'm stuck, and I see myself installing a very big helium tank somewhere here in the company. That doesn't make sense. Again, this is a noble gas. This is extremely wasteful. And I don't see a practical application in standard industry production runs. Just for this stupidly ambitious project of printing this in under 1 minute. What are your thoughts? Go down in the comments. Tell me everything you can see and read and notice from this model, and give me your thoughts on it. So again, I had a blast. First off, testing helium on my bespoke Benchy printing machine. And of course, you guys being here with me as well, having someone to show my results to and having a discussion with afterwards is a lot of help. There is a link to my Discord somewhere in the video description. There's a link to my Patreon. Thank you again. You can engage in the video comments. Tell me everything you see in this experiment, what your thoughts are, maybe stupid stuff that we can derive from that. So I was thinking there is a local diving school just around the corner. We have had the experience that more air, more better. So basically with this kind of setup I could hook up a air tank filled with 200 bars of air, which is a lot cheaper than helium. And we could blast, instead of 250 liters, which is pretty much maxed out in my system here, we could go with 500, 1000, you name it. Would that be a thing? Come up with anything in the comments and I try to make it happen. With that being said, thank you guys for sticking around all the way to the end. My name is Jan and I build stuff so you don't have to.